Hello everyone, welcome again to our chemistry class. We have here the periodic table of elements. As you can see, it consists of 118 known elements and each element possesses a charge, charges or valences, except for those that are newly discovered such as nihonium, moscovium, livermorium, tennessine, and oganesson that have unknown charges, and some of the elements under the noble gas group, such as helium, neon, and argon, do not combine with others forming compounds because they are chemically stable. Why do I talk about these charges? It's because they play a significant role in writing chemical formulas which will be discussed in detail later. Next, we have here some products found at home, such as Zonrox, which contains an active ingredient called sodium hypochlorite, the baking soda that contains sodium bicarbonate, the antacid tablets which contains calcium carbonate, hydrogen peroxide, and the alkaline batteries that contains manganese dioxide and potassium hydroxide. How do these names of chemical compounds be written as chemical formulas? So today we will be talking about writing of chemical formulas. But before we continue, at the end of this session, you will be able to define chemical formula, familiarize yourself with the steps in writing chemical formulas, and follow the rules in writing chemical formulas. Let's first define chemical formula. Chemical formula is a notation that uses chemical symbols with numerical subscripts to convey the relative proportions of atoms of different elements in a substance. Subscripts are small numerals which are placed and little below the symbols of the elements concerned. It represents the number of atoms combined. Another thing that is concerned in writing chemical formulas is the oxidation number. Oxidation number is a positive or negative whole numbers assigned to an element in a molecule or ion on the basis of a set of formal rules. In order for you to write chemical formulas, you need to follow several steps. The first step is to write the symbols of the elements and their oxidation number. The next thing is if the oxidation numbers of the metal and non-metal are numerically equal, simply remove the oxidation numbers. Let us have here an example. So we are asked to write the chemical formula of the potassium chloride. According to the rule, we need to write first the element and the oxidation number of potassium. Here we have K positive 1 and chloride, which is Cl negative 1. According to the next step, if the oxidation numbers of the cation and anion are equal, we will just remove the oxidation number and combine the two ions. So here, we have now the correct formula of potassium chloride, which is KCl. So another example is we are asked to write the chemical formula of the compound aluminum nitride. Again, according to the rule, we will first write the symbol of the element or of the positive ion or the cation, which is aluminum, and its oxidation number, which is positive 3. So we have here Al positive 3. And the symbol of the anion, which is nitride, with its oxidation number, and that is N negative 3. According to the rule, if they have the same oxidation numbers, we will just remove the oxidation numbers or omit the oxidation numbers and combine the two ions. So here, the correct formula of aluminum nitride is ALN. Another rule in writing chemical formula is when the charge in the positive ion is not equal to the charge of the negative ion, cross over the oxidation numbers and write them as subscripts. We have here examples. First, we are asked to write the chemical formula of zinc phosphide. According to the first rule, we will just write the symbol of the element and its oxidation number. So with zinc, we have here Zn positive 2. For phosphide, which is the negative ion, we have P negative 3. So you notice that the oxidation numbers of zinc and phosphide are not equal. So what shall we do is to cross over their oxidation numbers and write them as subscripts. In this case, the 2 here, which is the oxidation state of zinc, will now be the subscript for phosphorus. And the 3 here, which is the oxidation state of phosphorus, will now be the subscript for zinc. So therefore, the correct formula of zinc phosphide is Zn3P2. Another example is lithium oxide. Again, according to the first rule, we will just write the symbol of the cation and its oxidation number, and for lithium, we have Li positive 1. And for oxide, which is the anion, we have an oxidation state and the symbol O negative 2. So you also notice that the oxidation numbers are not equal. So therefore, we will cross it over and write them as subscripts. For lithium, the subscript of lithium will now be 2, and that 2 came from oxygen. And the 1 here, which is the oxidation state of lithium, will now be the subscript for oxygen. You notice that 1 is not written beside the symbol of oxygen. It is because it is understood that there is only one atom of oxygen in lithium oxide. Another example is sodium thiosulfate. Again, according to the first rule, we will write the symbol of the element sodium and its oxidation number, which is positive 1. And we have here Na positive 1. And for the polyatomic ion thiosulfate, it has the symbol S2O3 negative 2. Notice again that their oxidation numbers are not equal. So therefore, it will cross over and write them as subscript. In this case, the correct formula for sodium thiosulfate is Na2S2O3. Another rule in writing chemical formula is to reduce subscripts to lowest terms if possible. For example, we are asked to write the chemical formula of the compound tin 4 sulfide. First, we will write the symbol of the element and its oxidation number. So in this case, tin uses its oxidation state, which is 4, and that is Sn positive 4, and sulfide, which is S negative 2. According to the rule, if if the oxidation state of cation is not equal to the oxidation state of anion, so we will cross it over and write them as subscripts. So in this case, we had Sn2S4. So the 2 here came from sulfur, and the 4 here came from tin. So we are asked to reduce the subscripts to lowest terms if possible. Notice that both 2 and 4 are divisible by 2. So therefore, 2 divided by 2, and that is Sn. And then 4 divided by 2, that is 2. So the correct formula now of tin 4 sulfide is SNS2. Another is lead 4 oxide. Again, we will write the symbol and the oxidation state of lead, and that is Pb positive 4. And oxide is O negative 2. So their oxidation numbers are not equal. So therefore, we will cross it over and we will write it as subscripts. So here we have Pb2O4. You notice also that 2 and 4 are both divisible by 2. So Pb has an oxidation state of 1 because 2 divided by 2 is 1. And for oxygen, we have 4 divided by 2 is 2. The correct formula now of lead 4 oxide is PbO2. The last rule in writing chemical formula is parentheses are placed outside the polyatomic ion and the subscript is written just after the closed parentheses whenever the polyatomic ion is necessary. For example, ammonium phosphate. We are asked to write the correct formula of ammonium phosphate. So again, according to the rule, we will write the symbol or the formula of ammonium and its oxidation state. And we have here NH4 positive 1. And phosphate, which is PO4 negative 3. So notice that the oxidation states are not equal. So therefore, we will cross it over and we will write it as subscript. So since we are dealing with the polyatomic ion, and that is NH4, so we will then use open and close parentheses before putting the subscript of ammonium, and that is 3, which came from phosphate. And then right now, the symbol or the formula of phosphate, which is PO4. Now, the correct formula of ammonium phosphate is NH4 3PO4. Another example is calcium hydroxide. Calcium has a symbol and an oxidation state of positive 2. So we have here Ca positive 2. And hydroxide is a polyatomic ion with the symbol and the formula OH negative 1. So you notice also that their oxidation numbers are not equal. So therefore, we will cross it over and we will write it as subscript. So since we are dealing with the polyatomic ion hydroxide and the number of subscript or the subscript that we will put around the polyatomic hydroxide is greater than 1 and 2. So therefore, we will put a parenthesis around hydroxide before putting the subscript 2. So the correct formula now of calcium hydroxide is CaOH2. So let's wrap up. So chemical formula is a notation that uses chemical symbols with numerical subscripts to convey the relative proportions of atoms of different elements in a substance. Subscripts are small numerals which are written beside the symbol of the elements, and it represents the number of atoms combined. And in order for us to write chemical formulas, we need oxidation numbers. And we have the rules in writing chemical formulas. The first thing that we should do is to write the symbol of the elements and their oxidation numbers. If the oxidation numbers of the cation and anion are numerically equal, we just simply remove their oxidation numbers and combine the two ions. However, if the oxidation number of the cation is not equal to the oxidation number of an ion, we will cross over their oxidation numbers and write them as subscripts. And if the subscripts can be reduced to lowest terms, reduce them if possible. In writing chemical formulas involving polyatomic ions, we will put parentheses around the polyatomic ions if the subscript to be written around the polyatomic ion is greater than 1. Now that you know the rules in writing chemical formulas, it's your time to try to write the formulas of the following compounds: sodium hypochlorite, sodium bicarbonate, calcium carbonate, magnesium dioxide, and potassium hydroxide. That's all for today. Thank you and God bless.